All right. Looks like we're doing Trig, Lecture 4.5, Lecture 4.5 and 4.6. The student will review the law of cosines in preparation for finding the solutions of problems involving involving vectors, which is what we're going to do next week. So let's take a little review of the law of cosines. As we've done in the past, there are three laws of cosines. They're all based on this one. And these two, you can derive these from this one easily enough. These are what I'm going to be using. And I'm going to use them to perform whatever operations they ask me to answer any questions. It says find the indicated measurement, round to the nearest tenth. I want to find AC. And I remember that AC in geometry is the endpoints of a line segment. And if there's no symbol above it, that means the length of AC. So I want the length of AC, which is, I'm going to call that B because side B, small case b, is opposite angle B. That looks kind of like a 6. Try to make it look more like a B. That's a little better. Here we go. I'm going to use B squared is equal to A squared plus C squared minus 2AC cosine B, and try not to make any mistakes. So here we go. B squared is unknown. That's what we're looking for. It's equal to A squared, that would be 21 squared, plus C squared would be 29 squared, minus 2 times A times C times the cosine of B, which is 105 degrees. And we plug all this into our calculator, and that will give us B squared. So I'll take the square root of this, and that will give me B. B will be the square root of this rounded to the nearest tenth. So here we go. See what we wind up with. Hopefully I won't make any mistakes. No promises. Mistakes are something I seem to be good at. Plus 29 squared minus 2 times 21 times 29 cosine 105 equals, and I want the square root of that. I got 1597.241597. Take the square root. I got 39.96. Now, if we round 39.96 and it gives me 550509, and it goes off my screen. I want to round it to the nearest tenth. This will round up to a 10 and carry the 1, so that will be 40.0. B is approximately 40.0. What's my unit of measure? Inches. If I haven't made any mistakes. And let me check the answer key and see if I made a mistake. 40.0, yay! So there's using the law of cosines to find the length of an angle. I'm sorry, the length of a side. I can't even speak. There we go. Now, if I'd run across this problem, I just want to say, if I'd run across this problem and it said just find AC and it didn't tell me to use the law of cosines, the first thing I would have done is to try to see if I could use the law of sines. And when I realized I couldn't use the law of sines, then I would jump over to the law of cosines and do that. I always try to use the law of sines first if I can. Okay, here we go. Here we're finding a measure of angle A. Up here we found the length of a missing side. Here we're going to find the measure of a missing angle. So here we go. I want to find the measure of angle A. This is the angle I'm looking for. So what I'm going to do is just plug in, since I'm looking for A, I'm going to use the one that has A in it, A squared equals B squared plus C squared. They all have A in it, but starts with A. Minus 2AC, or BC, I'm sorry. Shouldn't talk while I'm writing. Times the cosine of A. Okay. I'm going to plug in everything. I'm not going to know A, and then I'll solve this for A. Now some people like to solve this algebraically, subtract B squared from both sides, subtract C squared from both sides, and then divide both sides by negative 2BC, and then plug the values in. That will work just fine too. I'm going to go ahead and just plug the values in and then solve. So here we go. I'll try not to make any mistakes. 25 squared is equal to 29 squared plus 15 squared minus 2 times B, which is 29, times C, which is 15. Okay. Cosine A. Now what I'm going to do is I'm going to isolate cosine A using just a little bit of algebra, and then take the inverse cosine of both sides. So I have 25 squared minus 29 squared minus 15 squared. All of this, see, I just subtracted these two from both sides, divided by this, negative 2 times 29 times 15. Divided both sides by that, and that will yield the cosine of A. So in order to find A, I want to enter all of this into my calculator and take the inverse cosine of both sides. So this will be the inverse cosine. Let's see if I can duplicate this. It's not going to let me, I don't think. Well, I tried. The inverse cosine of this will equal A. And that's if I haven't made any mistakes. I hope I haven't. I don't see any mistakes there. Doesn't mean I didn't make one, just means I don't see it if I did. So let's see what we get. I'll do it like this. Top of the fraction, I got negative 441. Now I'm going to do the bottom of the fraction. Negative 870. That's if I haven't made any mistakes. I'm really hoping I didn't. And now I can ignore these negatives because negative divided by negative is positive. I'll go the inverse cosine of 441 divided by 870. And make sure you close your parenthesis there. So here we go. 59.5. And I hope that's right. Let me scroll a little bit so you can, I hope you can see that. I think you could. Well, let me see what my key says. 59.5, I don't believe it. I didn't make any mistakes. So there we have it. I was looking for angle A, so I chose the law of cosines that started with A. And I plugged in everything that I could see. The only thing I couldn't see was the measure of angle A that I was looking for. And then I said, okay, well, I'm going to solve this thing for the cosine of A. I subtracted these two from both sides, 25 squared minus 29 squared minus 15 squared. Then I divided both sides by negative 2 times 29 times 15. I said, hey, that's the cosine of A. And I said, we're going to take the inverse cosine of both sides. That isolates A, and whatever this is will be A, if you don't make any mistakes. And it looks like I didn't, so yay. I simplified this, called it negative 441. I simplified this, called it negative 870, just to make it a little easier to put in the calculator. And then I said, well, this, I ignored my negatives, said 441 divided by 870, took the inverse cosine of that, got 59.5. So there we go. We can use the law of cosines to find missing sides or missing angles of oblique triangles. And again, always try to use the law of sines first because it's quicker. If the law of sines doesn't work, then jump over to the law of cosines. You can do this.